Today I would like to show you the CAN configuration. We have the possibility to write CAN output data and to read the CAN data from the CAN bus. The hardware connector CAN 0 is dedicated to CAN output and the connector CAN 0 is dedicated to CAN input. Okay, let's start with the configuration. Select Utilities, CAN, Combustion Data Publication, means CAN output. Here you should start with a DBC file where the values, the frames are defined. If not, you can start with these indicating all OBI 6. This is a standard file coming with the installation. Because we have here a 4-cylinder engine, I would like to start with a 4-cylinder DBC file. Click Next to come to the next dialog. On the left side you can see all the CAN frames which are defined in the DBC file, including the data fields and the size of the data field, a starting bit, and so forth. On the right side you see the assigned values coming from the OBI, the calculated indication results. The assignment is done by name automatically, but if this fails, you can see it here, you have to do it by your own. So select the signal, use a right click to change the association, and we select indication results, integral acceleration cylinder 1. The same for the timestamp. The timestamp you can find here, cylinder 1. Next one for cylinder 2. And the last one is the CPU load in the OBI. You can find it in status and CPU mean. Okay. If you are done, it makes sense to save this association for later, in case we need it again. So we say save. And we say, okay, the same name as our DBC file, 4-cylinder, can write OBI. Okay, go to the next page. Here we have two options. The best way is to use as fast as possible. That means you can see here the white bar relates to the curve is, in this case, let's say cylinder 1. That means after the end of the cycle, immediately the data will be fired out to the CAN bus. This gives us the opportunity in the CAN recorder to see all the transient behavior, also the dynamics better than the other option. If you click once per engine cycle, then you will get only all the frames for sure, but at the same point in time. And from my perspective, this doesn't make sense, because you will lose the dynamics. Sorry, and so if possible, select as fast as possible. What is important for this option? You have also to separate the CAN frames for each cylinder. So don't mix up, let's say, Pmax1 and Pmax2 in one CAN frame. Use two different CAN frames for that. Otherwise, the CAN manager and the OBI system have to keep the results, has to keep the CAN frames before firing to the CAN bus until the point in time when the next cylinder 2 is ready. So this will be not a good solution. Okay, once again, separate the frames related to each cylinder, select as fast as possible, select the baud rate, 1 megabaud in this case, and say deploy to target. That's it.